Let's look at one more example of that really quick. We're told again to suppose that x and y vary inversely, and we're asked to write an inverse variation function when given that x is 4 when y is equal to negative 1/5. So let's go ahead and use our structure for that we know an inverse variation should take the form y equals k divided by x. We know an x and we know a y, so we have that ordered pair. Let's go ahead and plug those in and solve for this constant of variation. Y is negative 1/5, and k divided by x, which x is 4. So we have negative 1/5 equals k divided by 4. We need to go ahead and multiply both sides by 4 to get k by itself. And 4 times negative 1/5 is negative 4/5 for that. So our constant of variation is negative 4/5. Let's go ahead and then use this to write our inverse variation function. We would have y equals negative 4/5 divided by x. And I don't really like the way that looks with fractions inside a fraction, so let's go ahead and simplify that a little bit. When you have a fraction divided by x like this, I can think of this x as just another fraction itself, as x over 1. So when I divide by something, that's equivalent to multiplying by its reciprocal. So here I have negative 4/5. Instead of divided by x, I can multiply by the reciprocal. The reciprocal of x would be 1 over x. And then when I multiply straight across, this gives me negative 4 on top over 5x. So simplifying this, cleaning this up a little bit, my function to represent this inverse variation would be y equals negative 4, all divided by the product of 5 times x. Like that. So there's how you go ahead and write your function. I thought I would show that maybe to address how to clean this up a little bit instead of just leaving it as something over a fraction or something over x like that. This looks much better mathematically. If I then wanted to use my inverse variation function to find y when I'm given an x value, like in this example when x is 2, I just go ahead and plug in 2 for my x. So I have y equals negative 4 divided by 5 times 2. 5 times 2 is 10. I have negative 4/10, which would simplify to negative 2/5 as a fraction. If you don't like the fraction, that would be negative 0.4 as an equivalent decimal. That's okay. That's not rounded. That's still exact. So I would accept either one of those. What if the problem wanted us to find x? X is a little harder to solve for. It's trapped in the denominator of this fraction. So here let's see an example where we want to find x when we're told that y is 3. Let's use our function. Let's plug in what we know. We know y is 3. So we have 3 equals negative 4 divided by 5x. So go ahead and solve this. I got to get my variable off the bottom here out of the denominator. I'm just going to multiply both sides by 5x. That would cancel out completely on this side. I need to multiply by 5x on that side as well. 5x times 3 is 15x. On this side, I'm just left with negative 4. And then to solve for x, I need to divide. I need to divide both sides by 15. And I have x is equal to negative 4/15. And that is a simplified fraction, so I'm just going to stop right there. X is equal to negative 4/15 when y was 3. And that's how you do that.